Okay, let's get started. Ladies and gentlemen, faculty, sponsors, students, friends and families, welcome to the Fall 2020 renewal of the Biomedical Engineering Senior Design Expo and Competition at Florida International University. I am Michael Christie, Associate Teaching Professor and Primary Instructor of our Senior Design Project course. What we will witness today is the culmination of a year-long project in which students learn the rudiments of design, manufacturing, and quality, and they engage the biomedical engineering community to offer their services and expertise in helping those entities to achieve their strategic objectives. Thereafter, they build and test their prototype medical devices. It begins in the first semester, where students with their industry or clinical partners. Then, they present their proposals before a jury of the faculty who provide feedback on their design and assist them in determining whether the projects qualify as a senior design project as prescribed by the Accreditation Board of Engineering and Technology, ABET. Upon successful completion of Senior 1 requirements, students move on to the second semester. And in the second semester, students build on the fundamentals and apply knowledge gained to design and build their prototypes in accordance with the project charters, and are required to demonstrate that the devices in fact meet the objectives of the project. The results of their work and the decisions of the judging panels will be on display today. Welcome to our awards ceremony. Allow me to introduce to you the leadership of our department. First, Dr. Anu Godavarty, Associate Professor and Undergraduate Program Director. And she'll be followed by Dr. Renu Jung, Wallace H. Coulter, Eminent Scholar, Chair of Biomedical Engineering, Professor and Chair of the Department. First, I'd like to call Professor Godavarty to the lectern. Professor Godavarty.
I'm just looking at the count of participants, and when I started thinking, what should I start talking about today? It was 90 students or 90 participants. Right now it's 103. I believe even if we had a live in-person event, we never had this many people in one time, in one room, celebrating the success of your students, your children, your family, and our BME graduates too, graduating undergraduate seniors in one shot. So for that, a big round of applause for all of you guys. So while many things were not possible because things are virtual, but many things have been made possible. And let's count on all the possibilities. The first possibility is to have all the parents and family attend this event, which usually our rooms cannot accommodate so many in one shot, so which is a great deal. And in spite of all the roadblocks that the students have faced, or all of us are facing these days, the resilience with which everybody made sure that they're not asked to complete a senior design tool with a prototype. They said even a simulations are fine. Even if you can just tell us the methodology, it's fine. But still, when I talked to many groups, they said, no, that's fine. We still are going to go and make it happen. I don't know how they made it happen, but they made that happen. A lot of the students were able to take it beyond just simulations. So once more, another big round of applause, because that's like telling that you know how to endure yourself in situations that is beyond, let's not use the word new normal and stuff, but things that are unexpected. And that's what makes you a true engineer. You're getting out into the real world and where things are going to be thrown at you. And this was the first biggest example with which you prove that you can work together as a team, even if it's virtual. You can make things happen physically, even if you're virtual. You can do a video presentation, even if you're virtual, and still enjoy and celebrate with your family, sitting right next to them. Most of you are with your parents. I can see that. A lot of high fives going on. So that is something that I don't think, even if I don't ever want to have a virtual, but I don't think we can get this kind of a virtual where we get to celebrate in a much different environment, but in a much more happier situation, because the accomplishment, the feeling that you accomplish something during a period where it is more challenging than any other BME graduating student had to face. I think that makes it even 100 times better. So for that, the last round of applause for everyone. There's a whole list of people we should thank for, but I guess everybody starting from Senior Design 1, Professor Sharastani, he's here too, with the Panther right in his background, telling me he was very fierce, and he passed on the baton to Dr. Christie, who as usual did an excellent job, to all the advisors who helped them out, all the sponsors who believe that the students can really do things even during this period that we are all stuck in, and trusting in them, putting the financial support into making sure that the projects are sponsored financially and other than the technical support that they provided. And to all the students in believing that your team can pull this off, to all our faculty and the staff to make this event look as real as we can get, except that Claudia doesn't have the ice cream for all of us now. So except that, I think the event has been a great success. Congratulations to every one of you. And with that, I pass it on to Dr. Jung to give her the next note of her thanks and talk.
Thank you, Dr. Godavarti. Welcome, everybody. This is the culmination of your time as an undergraduate student at FIU, in our college, in BME. And, you know, it is such a joy to see what you have ended up with. It has been, it's a testament to your courage. It is a testament to your family support. It is a testament to us as people who are able to deal with all kinds of things thrown at us. And it's a testament to hope that we will succeed, because we have a next generation, that is you guys, who are going to make engineering to improve the health of all of us. So you have done that in these past 2 semesters, taken concepts all the way through prototype. About a few weeks ago, we had, I think a week and a half ago, we had the industry day, and there were new industries from as far as Palo Alto and in Washington State, and they were asking, oh, do your students do any kind of project management? Have you taught them that? Do they have any idea of what does it mean to be in the real world? And I can't tell you how proud I was to say, oh yes, Dr. Sharastani, Dr. Christie have made sure that our programs are such that every team gets that training. Our faculty who are engaged with the students go over and over with it, and we pride ourselves that this is a unique experience that our students have, that they take clinical need, put it all the way through, and come up with an actual prototype. And really, with all the mess around us that we have, you have all shown that you are leaders, and you have been able to take on that challenge, and you have been able to put together things that we are going to look at pretty soon. We are going to have an opportunity to see some of those. So to your tenacity, to your ability to integrate information from across different knowledge spheres, and to your ability to persevere, and most importantly, to your dreams, I give you my 2 thumbs up from my personal side. And with this, I pass things on forward. I'm going to look forward to seeing you at graduation day, and of course, the big showcase for engineering later. Parents, thank you. Family and friends, thank you. Industry and clinical sponsors, thank you. We really, really, really appreciate what you have done for us. All right, on to the next step.
Thank you, Dr. Jung. I would like to highlight some of our accomplishments over the past year. And what we've seen are several improvements in our program overall. The first is that we see an increase in the number of students that are employed by sponsors. We also see that there's a strong increase in the number of students who are employed in companies who are engaged in projects that are similar to their senior design projects. We also see an increase in the average sponsorship in terms of dollars committed. We've been holding steady in terms of the number of graduates and the number of senior design projects. And so for the past few academic years, we've been graduating with 20 teams. This semester, there are 8 teams that you will see today, and in the spring, there'll be another 12 teams. We're proud to say that 100% of our projects are sponsored and are either sponsored by large companies, small companies, clinics, and even entrepreneurs. We've also seen, and you will see that today, that there's an increase in the number of continuation projects. The average sponsorship, the total sponsorship this semester was around $18,000. In terms of innovation and continuous improvement, that is a requirement for every course and every program in our department. And what we've done between myself and Professor Sharistani, who you will hear from later on, we've seamlessly integrated student transition from senior 1 to senior 2 through streamlining and harmonizing the documentation process. We've formally adopted advanced design and simulation tools as a laboratory in the senior 1 course. This includes the SolidWorks platform. We've increased our emphasis on estimating the development and prototype costs during the project definition stage. We've also implemented a growth in the use of advanced manufacturing and rapid prototyping techniques such as 3D printing. And this semester particularly, we've had to train students in the art of asymmetric manufacturing strategies, where they can leverage local, regional, national, and even international resources for component and systems manufacturing. Our keynote speaker today, had she not been called to duty, is Dr. Eileen Marty. Dr. Marty is the director of FIU Health and Travel Medicine. She's also the leading infectious disease doctor in our state and has national recognition and duties as well. Unfortunately, she could not be here today, but sends her congratulations to all of the graduates. Now, this event would not be possible without our sponsors. And so I'd like to express on behalf of the department, the students, and our college, our gratitude to companies such as Oxidine, the FIU Nicole Wertheim College of Nursing and Health Sciences, Jabil Circuits, Bioengineering Labs, and the Max Beidman Institute for Biomechanics. Thank you so much. We could not have done it without you. Thank you for your patience, your financial commitments, and the guidance and the opportunity that you've given to our students. Now, you will see today that there are 2 competitions involved in senior design. First, we have a poster competition where students demonstrate their ability to condense what would have otherwise been a longer presentation to communicate their ideas in only a matter of minutes. And we had several judges. The first jury were primarily graduate students who are in training, as well as some professionals from industry. And so today I'd like to recognize Tommaso Bengini, Ramon Castellanos, he's over there at University of Virginia, Teshawn Francis, our very own graduate student, Maria Carla Gonzalez, Asad Mirza, Carolina Monsión, Manuel Perez. These are all from FIU graduate students. They're doing their PhDs. Diana Romero, who is a former student and is now at the University of Miami. Aliyah Shell and Mr. Edgar Solorzano, who committed to doing this work. He's all the way in Germany working on his graduate studies and was a former student from our department. The second competition is the oral competition, and it's considered the heavyweight division. And all of our judges are from industry. These are folks who are working in either quality, manufacturing, R&D, and several of them devoted their time to go through the projects and to evaluate them. They also met several times because I understood that this year's competition was very close, and they had to take a deeper dive into the projects in order to come up with the winners. So I'd like to recognize Mr. Joe Aguila. He's from Tag 3 Engineering. Mr. Alex Capo. He's a senior test engineer from Author Sensor Corporation. Dr. Claudius Carnegie. He's an adjunct engineering professor. Ms. Melissa Gonzalez, clinical support engineer from Stryker Corporation. And Mr. Alfonso Hermida. He's a product development engineer from Tag 3 Engineering and Consultants. If you'd please join me in giving them a round of applause. Thank you very much.
Hi, my name is Joe Aguila. I work for Tag 3 Engineering. I graduated FIU BME in about 2013. I was the chief judge for this round of judging for the senior design projects. On behalf of all the judges, we want to say congratulations. You guys did an outstanding job, especially under the current circumstances. We were really impressed by all the presentations. It was very difficult for us to go through them all and choose the winners. So we just wanted to say, great job. You guys should be really proud of the work that you guys did. Thank you guys for giving us the opportunity to judge your presentations, and we look forward to seeing you out in the field, and best of luck with all your guys' future endeavors. Thank you.
And that was a word from our senior judge. Now let's meet the teams that are presenting their work today. First, Team 1. Team 1. And their project was XPF Night Splint. The members of the team are Kevin Fusco, Karina Gonzalez, Tisha Boudram, and Okioma Arinze. Their faculty advisor was Professor Anthony McGoran, and the project was sponsored by Oxidine. Team 2, also sponsored by Oxidine, and their project was a heel pressure relief sock. And the team members were James Guerrero, Stephanie Marin, Pablo Rodriguez, and Brenda Soto, and their advisor was Professor Anu Gadavardi. Team 3 was sponsored by the Nicole Wertheim College of Nursing, and their project was a 3D pediatric upper limb prosthetic with an electrical system. And the team, they were guided by Professor Ranu Jung, and the team members were Daniela Espinel, Annie Barona, Gerson Romero Moreno, and Renjadra Wadri. Team 4 was also sponsored by Oxidine. And may I say that Oxidine we've established a relationship with them over several years now, and they are quite happy with the work that our students do. And so you can see that demonstrated here, that they trust the work that our program provide and the value that we bring. Their project was the knee brace and oxetic polyurethane foam. And the faculty mentor was Professor Nick Soukias. And the team members were Sergio Rodriguez, Amir Duraki, Juan Murillo, and Taslima Taznova. Team 5, sponsored by Nicole Wertheim College of Nursing, and Health Sciences. Their project was a dynamic resistance orthosis, also known as DRO. The faculty member who was responsible for that team was Dr. Michael Christie. The team members were Ife Ajigabi, Susana Restrepo, Victor Ortega, and Juan Camilo Gomez. Team 5, sponsored by Jabil Circuits, faculty mentor, Professor Raj. Team members, Rayleigh Bonilla, Thelma Del Cid, Sade Edwards, Hai Nguyen, and Diego Sanchez, and their project was a spinal cord infrared miniaturized monitor. Team 7, sponsored by the Max Beardman Institute of Biomechanics at Mount Sinai Medical Center. The advisor was Professor Joshua Hutchison. The team members, Danielle Infantas, Milton Lugo, Bridget Monohar, Kivash Ram, and Eric Peralta, and their project was a force tension monitoring system for the central cable transport device during distraction osteogenesis. And finally, Team 8, sponsored by Bioengineering Labs Corp., faculty mentor, Professor Michael Brown. The team members were Jason Yifong, Galit Moshkovitz, Alejandro Alarcon, Latanya Roberts, and Marcos Gonzalez Perez, and their project was a sensory feedback device. And now, before we announce the winners, I would like for you to hear from a couple of faculty members. I promised that you'll hear from Professor Sharistani, who co-teaches the course with me, but I'd like to share with you a faculty member's perspective on senior design and the importance of knowing your fundamentals. Professor Zachary Danziger, please approach the lectern.
Well, let me start by saying I absolutely love reading the chat comments as all the teams were being announced. I can see that there's a lot of pride and celebration, and I think that's well deserved. It takes a special kind of commitment to decide to be a biomedical engineer and go through the program at FIU. And you can see that in contrast with some of the other engineering disciplines where they are made to be understood. You know, you think about mechanical engineering or electrical engineering, buildings and circuits. These things are made to be understood by people. And so when you are going through the design process there, things are much more laid out for you. But when you make the commitment to be a biomedical engineer, you have to face interfacing your designs with whatever nature has provided with you. I'm sure the teams that have been working hard this semester understand that when you have to build a device that interfaces with the human body or a culture of cells, there are so many complications that you can't foresee or understand. So it takes a very creative mind to be able to handle whatever these systems throw at you. And it's going through these kinds of courses, these kinds of design gauntlets that really prepares you for dealing with the interface of design and biology and medicine when you're out on the job. And I already know that so many of the students who have been excelling in the senior design projects here are already going on to do great things, both in jobs and in the university. So I hope that everyone who has gone through this process, who has filled in their reports, they have gotten their hands on working prototypes, or at least seen their dreams come alive and interact with biological systems through simulations, can take some profound satisfaction at an interesting journey and having prepared yourself for the skills you'll need to become biomedical engineers. I mean, this is really the future, right? This next few decades is going to be about biology and neuroscience and making our lives better through integrating devices that people create with the needs of the health of our human body. So you all are going to be a part of that. You're all going to have a chance to shape how that future is developed. So I hope that even though this is complete, you see a lot of excitement ahead because the journey is really just getting started. So congratulations to everybody and job well done.
Thank you, Dr. Danziger. Of course, always be yourself unless you can be a biomedical engineer. A wise man once said. Now I'd like to call Professor Sharistani. He's my confederate in terms of senior design. He teaches the Senior Design 1 course. And let me tell you, students arrive in Senior 2 very well grounded in the fundamentals. Professor Sharistani, if you're there, will you please approach the stage?
Oh, I'm here. Well, good afternoon, everyone. Well, thank you for this opportunity. I want to also echo a lot of the sentiments that was already being shared by Dr. Gadwadi, by Dr. Young, by Dr. Danziger, and also Dr. Christie. I cannot emphasize enough how important it is for what you guys are have accomplished throughout throughout this phase that we're going through. But and I have told, I think all the students who have gone through my class, obviously all the students who are here, they're hearing this. I tell them at the first day of the class that just since you chose this major and your major has the word engineering in it, you are a problem solver. That's all you are. The question is where the problem is and what the skills do you have so you can solve that problem. And so we started out by challenge of well, we're going to go and find the senior design project. Who are we going to contact? Who are the sponsors? And knock on doors. People don't answer your emails. People don't answer your calls. And you have to solve that problem. Then a few people answered, and then you have to go and convince them that you are the candidate that should be working on those projects. So that was a challenge that you have to overcome that. And all of a sudden, we are in a pandemic, and we have to get off the classes and get onto Zooms and learn how to work, remotely, and how to conduct ourselves with limited oxygen, with masks, and all of those things. So we said, well, we're going to have to overcome that. Let's solve that. And then it was more of a social distancing, and we couldn't go into labs, and we couldn't work in labs. And we, as Dr. Gowhati mentioned, we sort of even decided to sort of give up on that and say, don't worry about it, don't manufacture anything, just talk about it. And the teams as proudly came back and said, no, we want to learn, we want to do that, we want to show that we can do this. And congratulations to all of those who took that challenge, because the challenges are limitless. They come and they sort of, we're faced with it as a society, we're faced with it in the world, and we're faced with it as students and business owners, managers, teachers, sponsors. So it's very critical that we all recognize that this group, this 8 teams, was a unique group of teams that what went through. Now we are much better. Now we are prepared. Now we can deal with those things a little bit more easier. But that phase was difficult for all of us. So again, congratulations to all of you that you made it through. And really, I don't focus on who wins and who loses, because I think if you learn anything, if you solve the problem, if you could demonstrate your skills, then you already have won. And make sure that you highlight all those in your resumes, and make sure you take credit for all the work, and make sure you highlight that you did all of that during the pandemic and during the COVID, because that's what a lot of people are sort of trying to diminish the challenge, and why you didn't accomplish more. And you should have accomplished more. And you need to make sure that is understood, the conditions under which you have to operate. So the other thing I want to recognize is the school. I work with few schools. I work with UF, I work with UM, and I work with a few schools, and they ask for help and they ask for recommendations and all of that. But the level of preparedness and the level of expediency by which the FIU moved once the pandemic happened and got prepared and got the classes going, and everybody was already on remotes and they were already conducting classes, it was impressive at that time. And I want to recognize the school, the department under Dr. Young's leadership, and also the school. So it was impressive to watch, because I have the advantage of not being a full-time faculty. I'm an advantage of being an adjunct. I can only watch from the outside and see what's going on, and I can be the good judge of that. So again, congratulations for being able to get through all of this and be able to accomplish your goal. Now you get on to your next task, which is, what is the next problem I need to solve? So I would say, last parting words, go find the next problem.
Thank you, Professor Shahrastani. And now we're going to move into the presentation phase of this ceremony, starting with the poster presentations. Now, once again, poster presentations were short presentations where a student would have to condense all of the ideas and accomplishments in only a few minutes. This would typically happen pre-COVID at a conference or even in your own department to give a presentation and summarize your work. So there are 8 competing teams, teams 1 through 8. The final 4 teams were team 1, team number 5, team number 6, and team number 7. Honorable mention goes to team number 7, Danielle Infantis, Milton Logo, Bridget Monahar, Kivash Ram, and Eric Peralta. Congratulations to Dr. Hutchison and the Max Beardman Institute for Biomechanics. Their project, again, force tension monitoring system for the central cable transport during distraction osteogenesis. Congratulations. Let's give them all a round of applause. And in third place in the poster category, third place goes to team number 1. Team number 1, Kevin Fusco, Karina Gonzalez, Tisha Boudram, Okioma Arinze. And for their efforts, they will receive medals indicating the third place, the bronze medals, and a monetary award of $100 for their efforts, but a lifetime line on their resume for their accomplishments. Let's give it up for team number 1, XPF Night Splint, sponsored by Oxidine and also guided by Professor Anthony McGorn. Congratulations, team 1. Now the moment you've been waiting for. Second place goes to team number 6. Team number 6, congratulations. Rayleigh Bonilla, Thelma Del Cid, Shaude Edwards, Hai Nguyen, and Diego Sanchez. They were guided by Professor Raj. The sponsor was Jabil Circuits, and they came up with a spinal cord infrared miniaturized motor. Congratulations, team. We're so proud of you. Congratulations. And by default, I'd like to recognize then the winning team for the poster competition. Team number 5. Ife Adijugbe, Susana Restrepo, Victor Ortega, Juan Camilo Gomez. The faculty advisor was one Professor Michael Christie, and the sponsor was Nicole Wertheim College of Nursing and Health Sciences. Congratulations. And for their exploits, they will receive the gold medal for their efforts, along with $300 in terms of monetary award. Congratulations, team number 5, for winning the poster competition. And may I say that the team that came in second place also receives $200 along with the silver medals. But the moment belongs to team number 5. Congratulations for all of your hard work. Congratulations, guys.
Hello, everyone. We're Team 5. My name is Susana Restrepo. My teammates are Ife Adejugbe, Juan Camilo Gomez, and Victor Arteaga. Our project is the Dynamic Resistance Orthosis, also known as DRO, and our sponsor is FIU's Physical Therapy Department and Dr. Mark Rossi. Our faculty mentor is Dr. Michael Christie. We began by identifying the problem that at this time, there is no viable, cost-effective solution that simultaneously rehabilitates the knee and ankle joints in patients that suffer from osteoarthritis. A need for a rehabilitative device for the geriatric population that has undergone corrective surgery gave us a proposed solution of a therapeutic orthotic device that encompasses the lower limb while providing resistance to maintain proper alignment that strengthens the surrounding muscles, thereby reducing recovery times and improving the lives of these patients. The current modalities that are available limit the range of motion, only apply passive resistance, and are very costly. With the market requirements and design inputs in mind, we came to a design of a knee and ankle orthosis with hooks to attach elastic bands to provide dynamic resistance. A modular design allows for separation of the knee and ankle portions to allow for separate exercises of the knee and ankle. Now I will pass it on to Juan Camilo, who will go over the simulations and verifications.
Thank you, Susanna. Before manufacturing, we conducted a stress simulation on SOLIDWORKS, specifically on the hooks which are subjected to resistive loads. The results showed a factor of safety greater than 1 for all components. After manufacturing, we conducted several verification tests, which include measuring the max extension and the shortest adjustment in inches, as well as the range of motion of the knee and ankle using a goniometer. For our killer test, we use electromyography, which is going to measure muscle activation as a change in resistance. Now I'll pass it on to Susanna, where she'll discuss our accomplishments.
Throughout this project, we were able to accomplish a novel modular device that provides resistance to both knee and ankle joints. This low-cost and lightweight device is adjustable to a diverse range of patients. It provides a rehabilitative solution for the geriatric population, as well as those patients recovering from reconstructive surgery. It is also important to mention that it can be applicable to sports conditioning and general rehabilitation of the lower limb. For future work, we propose Bluetooth and EMG integration to a mobile app, the development of an articulating hip extension module, as osteoarthritis can also affect the hip, and accommodation of walking motion to achieve other exercises such as calf raises and squats. Thank you for your time.
Congratulations, Team 5. And now the main event. The oral presentation is a much more comprehensive presentation of the work that students have done all semester. You will see much more detail in terms of their results, their verifications, and prior to that, you will observe their formulation of the problem and their design concepts. Once again, the judges informed that the competition was very close amongst all teams. Of the same eight competing teams, teams 1 through 8, the final four are teams 3, team 5, team 6, and team 7. Honorable mention goes to Team number 3, honorable mention, Daniela Espinel, Annie Barona, Gerson Romero Moreno, and Renjendra Wadradi. And the sponsor was Nicole Wertheim College of Medicine, and the advisor was Professor Ranu Zhang. Their project was a 3D pediatric upper limb prosthetic with an electrical system. Congratulations, guys. Third place in the oral presentation competition goes to Team 6. Team number 6, Rayleigh Bonilla, Thelma Del Cid, Sade Edwards, Hai Nguyen, Diego Sanchez. Directed by Professor Raj, and the sponsor was Jabil Circuits. The project was a spinal cord infrared miniaturized motor. Congratulations, Team 6. Congratulations, Team 6. Now the moment we've been waiting for. Second place goes to team number 7. Team number 7 with an award of $375 and the silver medal. Danielle Infantas, Milton Lugo, Bridget Monahar, Kivash Ram, and Eric Peralta. Directed by Professor Joshua Hutchison. sponsored by the Max Beardman Institute of Biomechanics at Mount Sinai Medical Center, and their project, the Force Tension Monitoring System for the Central Cable Support Device during Distraction Osteogenesis. But ladies and gentlemen, the moment belongs to team number 5. Team number 5. Team number 5, Ife Adejugbe, Susana Restrepo, Victor Ortega, Juan Camilo Gomez. The sponsor was Nicole Wertheim College of Medicine. The professor in charge was one Professor Michael Christie, and the project was a dynamic resistance orthosis. Team number 5, congratulations. If my sources are correct, that was a clean sweep. Team number 5, congratulations. Congratulations. And for their exploits,
Hello everyone, we are
$750
Team 5.
and
My name is
another
Susana
set of
Restrepo. My teammates are
gold
Ife
medals.
Adejugbe, Victor Arteaga, and Juan Camilo Gomez. And our project is the Dynamic Resistance Orthosis, also known as DRO. We are sponsored by FIU's Physical Therapy Department and Dr. Mark Rossi. To dive into the scope of our project, we began by identifying the problem that there is no available effective solution to simultaneously rehabilitate the knee and ankle joints in patients who suffer from osteoarthritis. With this problem and the need for a solution in mind, we proposed a therapeutic orthotic device that encompasses the lower limb while providing resistance to maintain proper alignment and prevent the risk for muscular atrophy by strengthening the surrounding muscles. This device would be used in a clinical physical therapy setting where the therapist can implement this into their post-surgery recovery regime. This would impact our intended population by providing an easy-to-use, cost-effective device for at-home therapy, with the hopes of a faster recovery rate. With our sponsor, we identified the clinical need as a population of patients 60 years and older who have undergone corrective surgery and now require physical therapy. As can be seen on the graph on the right, the blue line represents knee osteoarthritis in both men and women, and it is the most prevalent type. It is also important to note that knee OA affects the ankle as these joints operate together as a kinematic chain through gait. We identified the business need due to the fact that there are about 500,000 cases of arthroscopic surgery for knee osteoarthritis in the US alone per year. These patients go on to require physical therapy, which can be very costly, hence the need for a low-cost design. As mentioned previously, there is a lack of solution that targets both of these joints with resistance, and current competitor designs are expensive and limit range of motion. There is also a growing need in the market due to comorbidities such as obesity and diabetes. We would also like to mention that our device is applicable to a market for physical conditioning and general rehabilitation of the lower limb. Now, I would like to pass it along to my colleague Ife, who will go over the current modalities.
Thank you, Susanna. The current forms of treatment are divided into 3 major types: passive, assisted, and resistive, with the passive being the continuous passive motion and assisted the motor-assisted device. As shown in the table, although these types improve the ability to bend the knee and are easy to use by the patients, basically doing the work for them, they do not improve the pain or function of the joints. They produce a slower recovery time and limit the full range of motion of the knee and ankle joints. They are also not portable and as a result, do not offer at-home therapy. On the other hand, the resistive type includes the senior design project of class of 2019, which we'll be improving upon. Although this device provides the therapeutic resistance to the knee joint, it neglects the ankle joint, which will be upgraded in our device, among many other features. For our market requirement, the device must span the length of the knee to the ankle. The device must allow for extension and flexion of the knee joints. The device must allow for dorsal and plantar flexion of the ankle joint. And finally, the device must provide gradual increments of dynamic resistance to the surrounding muscles during the movement of the knee and ankle joints. The engineering design inputs are shown on the right-hand column, which is addressed in the verification section of this project. Now I'll pass it on to my colleague Vic, who will take you through the evolution of our design concept.
Thank you, Ife. Our concept started by acknowledging that we had to improve and upgrade the previous design that only targeted the knee, as you can appreciate on the first image labeled as Concept 1. So according to the design inputs and market requirements, our design targets both knee and ankle. Our concept number 2 is a 3D assembly on SolidWorks that comprises all the features that were considered as must-haves as part of the project. Due to passing concerns on certain aspects and parts of the device, a few changes were made to produce concept number 3, or as I like to refer to, the start of the show. I want to address these changes from foot to knee. As you can see on concept 2, the distance between ankle and instep was very short and didn't allow enough room for the bands to perform at the higher capacity. Some of the changes also focus on replacing adjustability and the use of hooks to attach the circular bands. Moving up to the slotted metal strips, they provide the attachment of knee and ankle with adjustability properties. Furthermore, the knee portion of the design has a knee bridge that was modified due to a passing concern of the bands making contact with the knee of those patients with ongoing surgical wounds. The knee design also provides adjustability and has a cushion inside that provides a comfortable fit and aids in preventing lesions that may be caused by contact with the device. Last but not least, and much appreciated on the prototype, the use of 6 hooks that work together with circular bands are distributed on the top and bottom of the knee brace portion. This is in order to allow knee flexion using the middle hooks and extension via the lateral hooks. Now, going over the modular component, I want to emphasize that certain types of injuries or issues may require the dependence of the knee exercise on the ankle exercise. So the joints will need to be exercised simultaneously. In other cases, certain injuries or issues require separate and more individually focused exercises, which is why we have the unique feature of a modular design that provides a variability of treatment. The way we are able to achieve this modular feature is by detaching the metal strips on the sides. In regards to patent opportunity, we highly suggest that the sponsor pursues a claim, since after conducting research and patent lookup, we didn't find any modular therapeutic device that targets both knee and ankle for rehab purpose using elastic bands, or with a design that resembles ours. I'll pass it along to JC now, and he will go over simulations.
Thank you, Vic. Before manufacturing, we conducted a SolidWorks stress simulation on the hooks which are subjected to resistive loads. The results show a factor of safety greater of 1 for all components, meaning our device will not fail. The prototype was manufactured with PLA, except for the stainless steel bars that will outsource to a Colombian metal shop. Resistance was provided with elastic bands, and our device provides an affordable physical therapy solution. As my colleague stated, we have a modular design, which means our device can be used as 2 separate orthoses. For the subsystems, we use a wide range of material, ranging from Velcro for width adjustment, brass and stainless steel fasteners to attach each individual component, and for comfort, polyurethane foam. Next, I'll pass it on to Ife, where she'll speak about the bands.
Thank you, JC. The device achieves all 4 major exercises as required. The first 3 of the 4 exercises use different colors of circular resistant bands, giving specific ranges of resistance in multiples of 5. The last exercise, being the ankle dorsiflexion, achieves this through natural resistance by bending the foot towards the face. In addition, the uniform composition of the bands allow for the bands to be sectioned for attachment to the side hooks for the knee extension exercise. Now I'll pass it on to my colleague JC, who will go over the verification process.
Thank you, Ife. Our first verification involves taking the length of the max extension, which was 32.5 inches, the shortest adjustment, which was 27 inches. The team recorded measurements as well as 4 random subjects. A t-test was conducted, and the results of the t-test allowed us to accept the null hypothesis, meaning difference amongst samples is due to chance. Range of motion was verified using a goniometer. The range of motion of the knee was found to be from 0 to 115 degrees. Although this does not provide full knee flexion of 134 degrees, we did a root cause analysis on our original design input and found this to be overly stringent. Contemporary research also states 115 degrees after knee arthroplasty is considered successful. And with evidence gathered, proper use of our device will facilitate a patient to reach full knee flexion. Plantar flexion and dorsiflexion both pass a range of motion with 50 degrees and 20 degrees respectively. And our team members conducted the measurements as well as 4 random subjects. A t-test was performed, which allowed us to accept the null hypothesis. For a third verification test, we generate a stress and strain plot for 3D filament strip, which was 2 millimeters thick and with 20% infill density, the same density of our brace. The max stress of this strip was compared to the simulation max stress, and a ratio from thickness to max stress was calculated, which gave us a strong correlation between the simulation data and empirical data. For our killer test, we chose electromyography, which measures muscle activations as a change in resistance. Electrodes were placed on the rectus femoris for knee extension, on the bicep femoris for knee flexion, and on gastrocnemius for plantar flexion. A control of innate resistance was used at the beginning and gradually changed with resistive loads every 10 to 20 seconds. Raw EMG data was processed on MATLAB, and a root mean square was used to highlight how an increase in muscle activation is dependent on an increase in resistance. After completing the verifications, we were able to calculate the total product cost to be $136. And now I'll pass it on to Susanna, who should speak about global learning.
To be successful in our project, global learning initiatives were kept in mind. In regards to engagement, we found that across the world, between 10 to 15% of adults over the age of 60 suffer from osteoarthritis. In regards to awareness, we found that developing nations such as those in South America and South Africa have high incidence rates of OA, but a low treatment market, which is why it is so important to develop a cost-effective, efficient, and long-term treatment for OA. Access to affordable healthcare is a global issue, which we hope to remedy with our low-cost design. For perspective, our prototype was designed with inclusivity in mind. Affordability, adjustability, and ease of use were important factors when finalizing the design so that patients of all socioeconomic areas, patients of all shapes and sizes and ages can take advantage of the design. Now I will pass it along to Ife, who will discuss the future work for this project.
Thank you, Susanna. With the conclusion of this project, we as a team did extensive research into how to improve the device for future works. This includes firstly the use of Bluetooth/EMG integration that records and tracks real-time exercises and muscle activity to a mobile app. Secondly, with the rising issues in knee osteoarthritis, which affects the hip joints in addition to the ankle joints, there's a need for the development of an articulating hip extension model. And finally, there's also a need for a design that accommodates ballistic walking motion to achieve calf raises and squats, targeting other muscle groups in the limb. To summarize our accomplishments within this project, with the COVID constraints, we're able to outsource the manufacturing of our device to departments in FIU and as far as the welding company in Colombia for the metal leg arms of the device. In addition, we are proactive in using the resources here in the BME department to conduct our verification using knowledge and instruments from BME Lab 1 and 2. Also, it's important to mention that when compared to the current modalities used, the dynamic resistance orthosis provides an effective solution for simultaneous rehabilitation of the knee and ankle joints in osteoarthritic patients by meeting all the requirements needed to address the problem, as shown in the table. We would like to acknowledge and thank the following people that made this project possible and successful. Thank you for listening. Please, any questions?
Thank you. Thank you, Team 5. And at this time, I just would like to, as we approach the end of our event, I'd like to ask once again that the winners and also students and families are welcome to stay back, but students will be interviewed by our media outlet at FIU and the BME department. And of course, remember what BME is all about. We identify, conceptualize, brainstorm, collaborate, innovate in order to achieve. Thank you very much. This is our signature event, and I appreciate your presence from families and all of the sponsors and supporters, and we look forward to seeing you for some future cohort in the spring. Thank you very much, and with that, it concludes our official award ceremony. Thank you.